Hello again, everyone. So today we're going to solve a pretty long integration problem. So we need to find out uh, a volume, a solid revolution formed of this graph is rotated around about the x-axis. So if it's an axis, so that means we need a y square pi y squared from 0 to square root 3. So therefore, y is substitute, so become 4 pi times by this. So here's a very long fraction. So what I'm going to do is I'm going to use a partial fraction to solve. It's a pretty long process. Before doing that, please subscribe this channel if you haven't done so. But this channel now come to almost 138 videos so far. So this is a very big list of videos you can access if you subscribe the channel. All right, let's do this question here. We got the fraction. So we're going to try to use a partial fraction. So I'm going to do fx. So let fx do this. So I'm going to put into first two things in bracket. So I'll separate into x squared divided by x squared, just x divided by x squared plus 1. The other one was that. So now I'm going to partial fraction. So I'm going to use the partial fraction format. The first one was a, second was bx plus c. So I'm going to change to this. Now I'm going to choose three values for x, 0, 1, negative 2. Now, some people say, why you not choose negative 1? Because it'd be easy to decide that's 0. Why not doing that? Because we know the denominator is we got x plus 1. So so the x minus 1 will be prohibited because of causing undefined value for denominator, for fraction, because denominator cannot be 0. So I don't choose x equal to negative 1. So even the life will be a lot easier if you choose negative 1. You got the same answer, but mathematically it's not correct. So I choose a negative 2. So I'll establish three equations, 1, 2, 3, simultaneously solve them. So I've got three answers. A is half, C is half, and then substitute any of the equations, find that B is negative half. So therefore, my fx is become three fractions, first, second, and third. So now third one, I'm going to further divide, separate it into two fractions. Negative x combined with, so those two together, so I'm going to put them together as this. Okay, so now I've got second one and third one. So then I'll take the half as common factor. So you can see the half common factor. So I've got three fractions. 1, 2, 3. So now I'm going to take half divided by 4 divided by half is 2. So therefore my fx become three partial fractions. So I'm going to do individually. I'm going to call I1, I2, I3. So I'm going to do I1 separately. So I1, I'm going to use substitution methods. I'll put the x squared plus 1 divided by 2. So don't forget about half. So there'll be half of the log x squared plus 1 square root, substitute x square root 3 is 3, log 3, then substitute 0 into that. So that's 0 because that's minus 0. Log 1 is 0. So we know that. So the answer is half log 3. Second one, we do the same thing, plug. So second fraction is pretty simple, which is log x plus 1. So the answer will be plugging square root 3, big log square. Oh, my apology, sorry. I got a little mistake there. Plug there, plus 1. So first one was log 3 square is 3. 3 plus 1 is 4. So the answer will be log 2, because log 4 is a square, so the answer will be log 2. Second one, I'll be plus log 3 into become plus 1, then plus 0 into will be log 1. So the second one will be log square root 3 plus 1. Then the third one will be, I'm going to use the formula sheet. So the integrated third I3. So I3 be inverse of 10. Substitute that into plug log square root 3 become pi over 3 minus 0. So the pi. So now I'm going to combine them together. So therefore my volume is 2 pi. We're going to put I1, which is log 2, plus log square root 3 plus 1, then plus pi over 3. So now I'm going to combine those two together. So the answer, apology. So the total answer will be 2 pi. So 2 log become 1 log, become 2. Square root 3 times by 2 plus pi over 3. So that's my answer. Apologize for some coughing. Yeah. Okay, so that's all done. So this is a little bit more involved steps because of partial fraction. Partial fraction is patience. You need to find a right value to substitute to the equation to find the simultaneous equations. So hopefully you enjoying the video, and I got a little bit of mistake in the middle of something. I'll correct that. Thank you for be patient. And if you enjoyed the video, please give us the thumbs up. I'll see you next video.